Sketch the graph of the given function f of x equal x plus 2 divided by x squared plus 7x plus 6. First of all, we go ahead and factor the denominator of f of x. This equal to x plus 2 divided by x plus 1 times x plus 6. Now this will give us the domain of the function. The domain is all values of x so that x is not negative 6 and x is not negative 1. So in interval notation, negative infinity to negative 6, union with negative 6 to negative 1, union with negative 1 to infinity. Next, we take a look at the x and y intercept. The x-intercept, we let f of x equal to 0. This means x plus 2 is equal to 0. So then x equal negative 2. The y-intercept, we let x equal to 0. So f of 0 equal 2 over 6 equal 1/3. So here we have the x-intercept is the value. X-intercept is the point, negative 2, 0. And y-intercept is the point 1/3, 0, 1/3. Next, we determine the end behavior of the function. When we want to see what is the value that this function approached at x approaches to positive infinity and negative infinity. So the limit at x approaches infinity of x plus 2 divided by x squared plus 7x plus 6 is the limit at x approaches infinity. We divide the numerator and denominator by x squared. So 1 over x plus 2 over x squared divided by 1 plus 7 over x plus 6 over x squared. So this function approaches 0 at x approaches positive infinity. What happens if x approaches negative infinity? We still have 1 over x plus 2 over x squared, 1 plus 7 over x plus 6 over x squared. This still goes to 0. This implies that we have the horizontal asymptote of y equal to 0. 4. Let's determine the vertical asymptote. Well, f of x is undefined when x equal to negative 1 and when x equal negative 6. So the vertical asymptote, x equal negative 6 and x equal negative 1. Now that we have the information about the asymptote, let's go ahead and sketch and put the asymptote into our graph. So here we have a vertical asymptote. And we have the horizontal asymptote. Next, we would find all the critical points and determine the interval of increasing and decreasing. So to find the critical value, we take the derivative of f of x. So then f prime of x is equal. Here we use the quotient rule. X squared plus 7x plus 6 minus x plus 2 times 2x plus 7 divided by x squared plus 7x plus 6 squared. We expand this out. Simplify the numerator. Now to find the critical value, we go ahead and let f prime of x equal to 0. This implies negative x squared minus 4x minus 8 equal to 0. This means x squared plus 4x plus 8 equal to 0. This function is not factorable. It doesn't have a solution, so there is no solution here. This means our critical value are the value where the function undefined, x equal negative 6 and x equal negative 1. We will create the interval and see where is the function increase and decreasing. Okay. So we have the interval from negative infinity to negative 6 to negative 1, negative 1 to infinity. We use test value for each of this. So here's the numerator. We have negative x squared minus 4x minus 8. Denominator x squared plus 7x plus 6 square. And here we got f of x, f prime of x. Let's choose the test value x equal negative 8, x equal negative 2, and x equal to 0. Then the numerator in the first interval is negative. The denominator is positive. Overall, we get a positive. Overall, we got a negative. We have a negative here, a positive. So we get another negative. We get another negative, positive, and negative. What meant in this case, there is no max nor min. The function is decreased on all interval. In other words, f of x is a decreasing function. The next thing we do is we take a look at the inflection point and the concave. Let's go ahead and take the second derivative. So we know that f of x, f prime of x, is equal to negative x squared minus 4x minus 8 divided by x squared plus 7x plus 6 squared. So then the second derivative, f prime of x, f double prime of x, is equal to x squared plus 7x plus 6 squared times negative 2x minus 4 plus x squared plus 4x plus 8 times 2x squared plus 7x plus 6 and the chain rule 2x plus 7 divided by x squared plus 7x plus 6 to the fourth. Note that we have an x squared plus 7x plus 6 squared in the and the x squared plus 7x plus 6 in both terms in the numerator. I factor x squared plus 7x plus 6 in the numerator and simplify that with the denominator. What left over is x squared plus 7x plus 6 times negative 2x plus minus 4 plus 2 times 2x plus 7 times x squared plus 4x plus 8 divide by x squared plus 7x plus 6 to the third. Now simplify this further by multiplying that all out the numerator and combine like term. I get 2x cubed plus 12x squared plus 48x plus 88 divide by x squared plus 7x plus 6 cubed. To find the inflection point, I let f double prime of x equal to 0. This means we take 2x squared plus 2x cubed plus 12x squared plus 48x plus 88. We set this equal to 0. Now to find this 0, this function is not easy to factor. So what I did was I plugged this into a graphing calculator and get x equal to negative 2.927. That's about that. Now that we have the inflection point and we have the critical value from the previous step, we can set up the table for the second derivative test to see where the graph is concave up and concave down and the inflection point. Okay. So I create the table of value, the table of interval, negative infinity to negative 6, negative 6 to negative 2.927, negative 2.927 to negative 1, negative 1 to infinity. Okay. And we use test value. So here we have the numerator, 2x cubed plus 12x squared plus 48x plus 88. The denominator is x squared plus 7x plus 6 cubed and f double prime of x. We use the test value x equal negative 8, x equal negative 5, x equal negative 1.5, and x equals 0. So here we have positive, here we get negative, positive. So f double prime of x is negative. So here we have concave down in this interval. We get negative, negative. This makes positive, concave up, positive, negative, negative, concave down, positive, 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 concave up. This means we have an inflection point at x equal negative 2.927 and y is the value of f of negative 2.927 and this is 0.157. So let's collect all this information and put it onto our graph. Okay. So here we have a x-intercept Here we have the y-intercept. And this is -1, not 1. The vertical asymptote at -1. The y-intercept is at 1/3, 0. The inflection point is at -2.9270157. So the inflection point is somewhere here. Okay. And the graph is concave down from -infinity to -6. And we have a decreasing graph. Concave up from -6 to -2.9. Then we have a concave down. Then we have another concave up from -infinity to -1 to infinity. So here's the graph of after fact.